Okay, so, by their definitions, we're going to say on the circle, which segments and, lines are which. So if a radius is a segment that joins the center of a circle to a point on the circle, which of the following segments on that circle are radii, would be the plural for radius. Morgan?
AO.
AO is one. Sarah? OC is one. Bless you. And another one, Aaron? OB, good. A chord is a segment whose endpoints lie in a circle, so which of those are chords? Okay? RS. Volpe?
AB.
AB. I think that's it. A diameter is a chord that contains the center. Sarah?
AB.
AB. Good. And a secant is a line that contains a chord. Sarah? RS. Lines, remember we draw the arrows in the ends. So secants are lines and chords are segments. Mac?
AB.
AB. Okay, so we just need to get familiar with those definitions. Any questions about that? Okay, so this is pretty much an introduction to circles. I will just post this and you can finish your notes for your homework and we'll do the rest
Let's go through.
Yes.
So Monday's homework, we don't want that word for
Yes, and it's on the notes.
Thank you. Do you have my flashcards with me? Can I have them back? Thank you. Oh my goodness. That's we have a vocab test. Paige, can I see them?
I don't want to put your cards in mine. Well, you know what? They work better.
Oh god.
Sorry, go ahead, go ahead.
Yes, but Aaron, this is the main habit. So if you don't understand, we're doing
Sorry. I love that song. So good.
Good song.
Is it new?
What? I don't understand.
It's kind of inappropriate. It's actually very
Well, obviously,
Most
the
songs
title
are.
is dirty.
Just listening to the title.
I felt like listening to the snake guy dancing. It's like, ew.
That was weird.
Oh my
The snake in the grass.
Like,
Doing on the
Okay.
I'm watching a French movie. It's really
Oh.
weird.
It's very
When you
strange.
guys went to the ballet. Is that what you're talking about?
No. We're talking
We're
about
reading a French book, and there's
Oh.
a movie.
watching the movie in French class.
And
It was,
there
Bob
but it's a
Fosse.
musical as well. Like they made it a musical, so they're all like singing and
Dancing in the mirror.
It's like a guy is supposed to be a snake, but it's like played by a human instead. So he's like pretending to be a snake, and he's like
And he's
running around and singing.
like-
and it's really
It's so
I thought
weird.
that's rather humorous. No?
I-
Are you just annoyed by it?
It's
or-
funny. It's
this
song
it's
went
funny
on
to
forever. Like we thought he was gonna stop. Nope, kept going. Oh, you're gonna stop. Nope, kept going.
Oh, wow. Okay, get out your homework, please.
I didn't get 6 and 7.
and 7?
Were we supposed to do 6 and 8?
We didn't have to do
No,
that.
not
You
8.
have to do 8.
I think I should do it. No, did I do it right now?
So there's obviously, like we said yesterday, a lot of different ways to do these. 6 is mainly the whole thing about the constant velocity it's up doesn't really matter as far as your diagram goes, because if it's maintaining a constant velocity, then it's not accelerating in that direction. So I guess basically, well, yeah. So you would have to add, I don't know if they're just trying to reiterate the fact that up should have a constant velocity. But that should be assumed. If there's only an acceleration to the right, then the velocity everywhere else should be constant, because that means it's not accelerating, it's not changing. So the only acceleration is to the right. So since they've given you 4 newtons up, you have to add 4 newtons down to make sure that that is balanced. And so I guess there's really only one way to do this one, because they've also given you 10 newtons to the right. And so if it's going to be 4,
7. Or
Then-
no, wait.
then how many do we have to make going this way?
6.
So that one, there really is only one way to do that. So 7 basically means there's no acceleration. So if there's no acceleration, what do you have to do with the forces? Balance them, yeah. So you have to add at least 2. You know what? 6 and 7 also are 2 kilograms. I didn't notice that before. Because you know it's force equals mass times acceleration. So with all the other ones, the mass was 1. So it was basically just force equals acceleration. But since on the last 2, there's a mass of 2, then that actually means the force needs to be 2 times the acceleration. So that's going to change this number. So if the force, excuse me, the force is going to be 2 times 4. That means the force is going to be 8, and so 8 newtons to the right, and so that means this has to be what? So mass is 2, the acceleration is 4, so the force has to be, in this case, 8 newtons to the right, and so, yes, this would be actually 2 newtons. Skylar? Okay, so there was 2 equations for Newton's second law that we wrote in our notes yesterday that were actually reviewed, but we hadn't done them in a while. Yes?
I did. Oh, okay, never mind.
Yes?
I
Good?
did.
Okay. Alright, so for all the other ones, the mass was 1, so 1 times A is just A. But for the last 2, it's 2. So for number 7, if this is 2 and they want, it actually doesn't matter for number 7 because they still want them to be balanced. So they want a 0 acceleration. So in that case, it doesn't matter because it's 2 times 0. So the force still needs to be 0. Right? So the only one that 2 affects is number 6. So if they want it to be constant velocity, and they currently have 10 and 5, we have to add at least 2. What can we add? What do we have to add? First we have to add, Lauren?
5 to the right.
Yes, we have to add another 5 this way to balance out the 10. And then we're actually going to add 3 in this case because we'll need an up and down. And it doesn't matter how much you make that. Say 8, it doesn't matter. As long as they're balanced. So if they have a constant velocity, then there's no acceleration, that means all the forces must be balanced. Okay? So that was a nice review of force diagrams, yes? Alright, and today we're going to be doing, it's also going to be pretty much review of just adding vectors using adding force vectors instead of, we've most of the time been adding velocity vectors throughout this chapter. That's not what I want. I had a feeling it was getting mad at me, so I was doing too much stuff.
No, focus.
How long has that been off?
Focus. Sorry.
Should have just used one notebook for all the classes I have.
Oh, good.
That's what I did. I got one of those in each section. I should.
Okay. We're gonna talk about Fido today. You don't have to draw Fido, but you need to draw his vectors.
Looks like it's like choking him or something.
It's just a leash.
When I
You
put
seem
my
pretty
dog
happy
on
about
a
it.
leash, he won't
He won't walk.
walk. He just lays there. If you want to walk him, he'll just walk behind you.
That's
Okay.
funny.
I would have never trusted my dogs to do that.
Well, my dog is a Chihuahua.
Oh, well,
They're like different species.
They are.
a different species.
They're not counted as dogs.
Do you like them? No.
I have 3. I don't like any of them.
3
Oh, you
chihuahuas.
liked Radar.
Rager's getting full, so he doesn't pee.
I feel like that's the problem with small dogs in general. They just go to the bathroom everywhere because they don't care.
Really?
Yeah, because they're so small that their mess isn't that big, so they can just go in one part of the house and then.
Well, plus, we have a hard time getting him to go outside when it's this cold out, because he's like this big. Like, freeze right when he steps out the door.
I was wondering what people did with their dogs, like, I guess you'd have to like shovel out your backyard so that they could go out and go.
Well, these dogs go in the litter box.
They do? What kind of dog does she have?
Greyhound.
Yeah.
But it's, so they're big.
It's
Italian
type.
Greyhound.
No, they're like
No?
this tall.
They're like miniature Italian
Oh,
Greyhounds.
I thought
They're like
greyhounds were bigger.
super skinny, like shake all the time.
They're always like,
They're weird looking.
they're so cute though.
I think they're kind of ugly.
I don't really like them. They just like look sad. I'm afraid that I'm gonna break them whenever I eat them.
Yeah, that's true. I hate that.
I just
feeling.
don't really
Or you
like
can
that.
like feel their bones.
Yeah, it's very
My dog's just a brat because she's like Queen Shiva. So
What kind of dog do you have?
A Shiba Inu.
Oh, okay.
She's. She just doesn't listen at all.
You had a bad dog experience, Skylar?
Well, once my childhood dog died, I just didn't have anything.
Was it a chihuahua?
No, he was a sheepdog mix. He was a big dog.
What's the other problem with dogs?
They died. I can't wait for these dogs to die.
And cats. And pets in general, they don't last as long as we do.
We've had like a zoo in my house. The only thing we haven't had are cats and birds.
My guinea pig lived for 16 years. Or no, that's an understatement. Or that's an overstatement. 10 years. But it's just a pretty long time for a guinea pig. Yeah.
My brother got bird for his birthday, lasted 3 months
Did
when
he
it
pierce
died.
his, did he really pierce
Yes,
his ear?
he did. When it died,
He pierced its
broke down.
ear?
No, his ear.
Oh, his ear.
I saw a picture on Instagram and he was like, pierced my ear at school today like a boss. And I was like,
Yeah.
what?
At school?
Ow.
Ow, that would hurt.
Some
person did it for him.
Where? Like in the bathroom or something?
Something.
Oh my gosh, Renee.
I know. I came home and I was just like, wait, what happened? And they're like, oh yeah, Kate Pierce was here. And I was like, oh.
Wait, were
Did
your
he get in
parents-
trouble?
Were your parents okay with it?
Not my dad, but my mom was like, oh well, what you gonna do? He's a 14-year-old boy and
He's only
he's going to
14
Snyder.
now. That's not like that old.
Huh?
That's not that old. Like 14.
Going to Snyder. It's kind of, I
It'll
don't know.
close back up. It's not like you got a tattoo or anything.
Yeah.
Or like Pierce's
Well, I
like
think
navel or
people-
something.
My dad was all like, this, you did not ask, that. First it's gonna lead to
That's
this,
a
and
really
then
good dog.
And he's like, then we're gonna
She's really good at drawing.
I said you
But it
don't
looks
draw
like
the
a
dog.
cat.
Okay. Back to physics, I suppose, if you're not done ready. So we've been doing, like I said, we've been doing velocity vectors and adding them, and this is no different. So anytime a force vector is directed at an angle, then we can use the trig functions to determine the two components. So, for example, a chain is exerting a 60 Newton force. So this is 60 Newton force upon Fido at an angle of 40 degrees above the horizontal. Find the horizontal and vertical components. So this would be the same thing basically as if we had two chains pulling on Fido and one was straight up and one was straight horizontal to the ground. And so we just need to find the components. That's the same as what we've been doing. So the horizontal force component we could call F of X, I guess, not F of X, but, and then the vertical force component. So to get Fx, it would be the cosine of 40 equals Fx over 60, or in other words, the x component of the force would be 60 times the cosine of 40. Which is
Hey Renee, can you hand me my calculator?
45.9, about 46. And so that would be 46 what? Newtons. Good, so about 46 newtons horizontally. And to find the vertical force, what would we do?
39. Sorry.
The sign.
Right, that would be the sine of 40 equals the vertical force divided by 60, or in other words, 60 times sine 40. So we've been doing this. This is just with force instead of with velocity. It's 39, so
Yes, because it's 38.5.
39 newtons.
So you don't have to do like, you don't have to find the resultant. Oh wait, no, never mind.
Because they gave that to
Yeah,
you.
they
That's
gave
what we
it to you.
started with, the 60.
Right. Okay.
Okay? And again, you don't have to draw the dogs here, but as the angle that the force makes with the horizontal increases, the component of force in the horizontal direction decreases. So what that means is, these aren't necessarily the best to illustrate that, I guess, but say we have a 30-degree angle. In that case, the horizontal force, is going to be longer than if we have a 60-degree angle.
There's a spider.
You got it? Handle. If you have like a 60-degree angle, the horizontal force would be less and the vertical force would be more. So as the angle from the horizontal gets bigger, the horizontal component of the force gets smaller. So the first dog is at 90 degrees, so that has no horizontal effect, it's only vertical. If it's 0, it's only horizontal, has no vertical effect. And depending on the angle then, depends on if it has more horizontal versus more vertical effect. Does that make sense? Questions about that?
So you said the steeper the angle is, the less horizontal it has then?
Right.
My drawings of dogs are really bad.
They're trouble.
It's
Okay,
like a
good.
circle.
Alright, let's do some multiple choice.
Should we create it twice?
No, I just did the one. That was so good.
Yeah, it looks like identical.
Hmm?
So it looks like it's identical.
Okay, you can put these in your notes as well. So determine the x and y components of the force for 100 Newton force directed at 30 degrees CCW.
What did the last thing say?
Basically that's just 100 Newton force, 30 degrees CCW, what are the components of it?
$86.6 and 50.
Good. Okay, and this is actually gonna illustrate the point that I was just trying to make. Because in this one, we have the same 100 Newton force, but this time it's directed at a 60-degree angle. So what would the components of it be?
Would they be like switched?
Well, it's just a different degree, right?
Right,
What's the same answer?
But they're different, like the f of x is this time it's like 50 and f of y is like 86. Or it's
I got like switched answers. So
Right.
for like the cosine you get 50. And
so the two together will still make up the 100 newtons, but in this case, it's making a greater angle with the horizontal, so the horizontal is less and the vertical is more. So the more steep it comes from the horizontal, the less the horizontal component of the force would be, and the more the vertical component of the force would be. Okay? Alright, so a force is exerted in a direction of 330 degrees. Which diagram best represents the relative magnitude and direction of the east, west, and north-south components? So which of those, if you add them together, would have a resultant that would be about 330 degrees? Remember head to tail. That was a good guess. It's in the right quadrant.
The second one.
Yes.
So it doesn't matter what way you're. I was putting them together wrong.
Okay. It would have to be either the second or the fourth, so they're both going down and to the right. But, so that's just a judgment call as how far right you would need to go to make 330 versus how far down you would have to go, which would be the second one. Okay, in this case, which one would be 240? Which of the two will we be choosing between?
Is it the second one?
Second and third, so do you think it's the second one or the third one? Second one? Good.
Yay.
So it has to go down and to the left to be 240. Okay, 300.
Third one. No. Never mind.
Be the first one. This is the third.
Oh, I was right.
So they're both down and to the right, so it has to be down into either the first or the third, but 300 would be more like that. Judgment call. Okay, 210.
First.
Good. And 150.
Yes. Get that. No. Seems to.
Good. Yeah, either the second or the fourth, so yeah, fourth. Okay, here we go. Forces with specific directions were resolved into the x and y components, match the given directions with the corresponding set of components. So, 30 and 60 would both be in which quadrant?
First.
The first quadrant, so which two will those have to be?
The first and
First and the
The
fourth. Okay, so which one would be 30 and which would be 60?
first one is 30, fourth one is 60.
Okay? And then we had 210 and 300. Down and to the right would be 300 and 210 would be down to the left. Good. Okay, so which one's gonna be 30?
Third one.
Third one, up and to the right. Okay, which one would be 120?
Fourth one.
Yep. Which would be 240?
The second one.
Good. And so 330 would be that. Okay, 60 Newton force makes a 40-degree angle. We already did, oh, okay, never mind. With the horizontal, if the angle is decreased towards 0, the x component of the force value will do what, and the y component will do what?
C.
Good, so the x component of the force will increase as it gets less, and the y component will decrease. Okay, same with this. The 400 Newton force makes a 60-degree angle with the east. As this angle is increased towards 90 degrees, so meaning in this case it's going down to 90 degrees from the east. That's not, so more like 270, what we would normally say. The x component will do what, and the y component will do what? Good. You don't need to do that, we're good at that. Okay, good. Okay, so this is basically review of forces and then more talking about which